You're listening to DTFHN for July 6, 2026. I'm your open source until proven otherwise host, Jack Haxman. We are your daily tech feed for Hacker News, a website where people who read the fine print argue with people who ship the fine print. Today, the question is, who owns what? And the answer keeps changing, depending on who you ask. Let's pull the thread. Let me make the case against caring about this. We have train apps. We have timetables. National Rail has a website. Every rail operator has their own tracker. Why would anyone need another map showing dots moving across Britain? Because none of those things actually show you what's happening. They show you what's supposed to be happening, filtered through the operator's own reporting. Signalbox does something genuinely clever. It figures out which train a device is on by matching smartphone sensor data against known train trajectories. No GPS beacon bolted to the locomotive. No official data feed that the operator can lag or fudge. Just physics, algorithms, and the fact that a phone on a train moves in a very specific pattern that matches one and only one service. Pull that thread. If you can identify any vehicle's trajectory from commodity hardware, you've built an observation layer that doesn't need permission from the thing being observed. The rail operator doesn't grant you access. The infrastructure authority doesn't hand you an API key. You just watch, match, and publish. That's a fundamentally different architecture than the government-run alternatives. And the comments section is a beautiful tour of those alternatives. France has one. Czech Republic has one. Sweden, Hungary, Denmark, all with their own official maps. Every single one depends on the transport authority deciding to make that data visible. The engineering here deserves real admiration. Matching a noisy smartphone accelerometer and gyroscope signal to a specific train on a specific track at a specific time is a hard signal processing problem. You're working with consumer-grade sensors, inconsistent sampling rates, tunnels that kill GPS, and stations where multiple trains overlap spatially. Getting that right, reliably, in real time, is craft. And the architecture matters. When the observation layer is independent of the system being observed, you get accountability for free. Delays aren't reported by the entity responsible for them. They're measured by the people experiencing them. That's not a feature you can bolt onto an official dashboard. It's a property of who controls the data. The comments reveal something wonderful. Rail enthusiasts across Europe have been building and sharing these tools for years. Each one a small act of making infrastructure legible to the people who use it. Signalbox just found an especially elegant way to do it without asking anyone's permission first. Moving on. In 1995, Borland and Microsoft were locked in a compiler war. Turbo C versus Visual C++. Each release a little faster, a little more optimized. Each company convinced that owning the developer's toolchain meant owning the developer. They were right about the strategy and wrong about the outcome. GCC was already out there, quietly compiling the future. The proprietary compilers didn't lose on features. They lost on architecture. When your tool belongs to a company, your workflow belongs to that company. OpenAI just announced GPT-5.6 Sol Ultra for Codex, and the details matter more than the branding. One commenter dug into the source code and found what Ultra actually means. It's not a new effort level on a single model. It's orchestration, sub-agents, multiple agents coordinated on a single task. The same pattern Claude Code uses with its own multi-agent dispatch. This is genuinely interesting engineering. Breaking a complex coding problem into subtasks, farming them out to specialized workers, synthesizing the results. That's not a marketing gimmick. That's a real architectural choice, and it works. The inference cost story deserves attention too. The information reports OpenAI has halved their inference costs. Run that forward. If you can cut the cost of running a subagent by 50%, you can run twice as many of them. The economics of multi-agent coding just changed. Every cost reduction in inference is a capability expansion in orchestration. The engineers who figured that out deserve respect for the craft. But here's the question this show always asks. Who controls this system? A corporate commenter already has access on their enterprise account, watching management present scoreboards and productivity metrics. The tool works for you, but it reports to your employer, running on infrastructure controlled by OpenAI, governed by terms that can change quarterly. The architecture is closed at every layer. Meanwhile, the same subagent patterns exist in open frameworks. LangGraph, Crew AI, the Cloud Agent SDK. The orchestration technique isn't proprietary. The deployment is. And that distinction is everything. When Borland went bankrupt and Microsoft deprecated Visual C++ 6 times over, GCC kept compiling. The code that ran on open infrastructure kept running. GPT-5.6 Sol Ultra is probably excellent. The multi-agent approach is sounding endearing. The cost reductions are real. But the most interesting thing about this announcement isn't what it can do. It's that every technique it uses is available to anyone willing to build on open foundations. The proprietary version gets the press release. The open version gets the future. Now let's talk about something that hasn't gotten nearly the attention it deserves. It's a Boolean. That's the detail worth pausing on. The Art Institute of Chicago maintains a public API for its collection. Over 100,000 works, searchable, browsable, documented. And buried in the schema for every artwork object is a field called has not been viewed much. Not a view count, not a percentile ranking, not a popularity score you could sort descending and gamify. A Boolean, true or false. Has this piece been seen or has it been overlooked? The threshold, if you dig into the source code, is 200 views since January 2010, 16 years of the modern web, and fewer than 200 people clicked through. For context, a mildly popular tweet gets 200 impressions in the time it takes to read this sentence. There's a design philosophy encoded in that field name. In 1998, when Google launched, the core innovation of PageRank was treating the web as a popularity contest. Links as votes, attention as authority. The more something was seen, the more it would be seen. Larry Page and Sergey Brin built the most powerful feedback loop in the history of information retrieval, and every recommendation algorithm since has followed the same logic. Surface what's popular, bury what isn't. Attention compounds like interest. The Art Institute did something subversive. They flagged the opposite. They took the long tail of their collection. The pieces the algorithm would deprioritize. The works that PageRank would never surface. And they gave that obscurity a name. A queryable, filterable, machine-readable name. You can hit their API right now and ask, show me everything the internet has ignored. And because this is an open API, anyone can build on it. Someone already built a browser that serves you random neglected works. The comments are full of people sharing what they found. A 19th century Japanese woodblock print of a summer moon, a painting called Honorable Mr. Cat. One person compared it to borrowing library books marked for disposal. Another mentioned Forgotify, the service that played Spotify songs with 0 listens, where every play destroyed the thing that made the song eligible. That paradox is real, and it's fine. The point was never to preserve obscurity. The point was to make the invisible findable. The Art Institute didn't just digitize their collection. They gave neglect a data type: open data, open schema, open invitation. The tools exist. The archive is waiting. Go look at something nobody else has bothered to see. We talked earlier about tools that respect you. Organic Maps takes that principle and draws you a whole world with it. What does it mean to be lost? Well, not lost as in confused or endangered, but lost as in unreachable, untrackable, present in a landscape without broadcasting your coordinates to a server farm in Virginia. There's a concept in ecology called rewilding, removing the infrastructure of control from a landscape and letting the original systems reassert themselves. You don't add anything. You remove the fences, the drainage ditches, the managed paths. The land remembers what it was. Organic Maps is rewilding navigation. Strip away the telemetry, the ad targeting, the constant phone home heartbeat, and what remains is the original function. A map that tells you where you are and how to get where you're going. Nothing more, nothing taken. 6 million installs as of late last year. The entire application works without a network connection. Download your region, disable your radio, and your phone becomes what it should have been all along. A tool that serves you without reporting on you. Contour lines, elevation profiles, hiking trails, cycling routes, turn-by-turn navigation, all of it running on OpenStreetMap data, which is itself one of the great quiet achievements of collaborative knowledge building. Thousands of contributors mapping every footpath, every unmarked trail, every shortcut through a park that Google has no financial incentive to show you. The comments around this project reveal something worth sitting with. There's a fork called Co-Maps, born from governance disputes. Concerns about ads creeping in, about previously open code going proprietary. This is the tension that lives inside every open source project that gains traction. The license is Apache 2.0. The code is forkable. And when the community perceived a drift from principles, they exercised exactly the right that open architecture provides. They forked. That's not a failure. That's the immune system working. Closed systems rot quietly, open systems fracture loudly, and both halves keep growing. The serious point underneath all of this is about what we've normalized. We've accepted that knowing where you are requires telling a corporation where you are. We've accepted that navigation is a service rendered in exchange for surveillance. Organic Maps. And its fork. Reject that premise entirely. The math works. The maps render. The GPS chip in your phone talks to satellites, not to add networks. Privacy-preserving navigation isn't a compromise. It's a restoration. The tools exist. The maps are waiting. Go get properly logged. Moving on. Parametric CAD is a constraint satisfaction problem. Every dimension depends on other dimensions. Change the radius of a hole and the wall thickness adjusts. The bolt pattern shifts. The clearance recalculates. This is fundamentally different from the mesh generation game most AI 3D tools play, where you get a beautiful blob that no mill or printer can reproduce without manual cleanup. Corel claims to bridge that gap. Text prompt and manufacturable parametric model out. Let me argue that this is impossible. Parametric modeling isn't shape generation. It's relationship encoding. A bracket isn't a shape. It's a set of constraints that produce a shape. The fillet exists because the material has a minimum bend radius. The hole spacing exists because the mating part dictates it. An AI generating a parametric model needs to infer not just geometry, but intent. Why each dimension exists, and what it's coupled to. Language models are famously good at producing things that look right. Parametric CAD punishes looking right. Either the part fits or it doesn't. Either the wall thickness supports the load or the bracket fails. And yet, one of the Hacker News commenters reports genuine success generating parametric models through a different path. Feeding OpenSCAD, a programmatic CAD language, through large language models. The code compiles or it doesn't. The geometry is valid or it isn't. There's something structurally honest about that approach. The model writes a program. The program produces a shape. The shape is deterministically reproducible. No hallucinated vertices. No non-manifold geometry hiding in a mesh. The early results from Carl suggest the gap between promise and execution is still wide. Open-ended prompts produce minimal geometry. Specific requests return adjacent but wrong objects. This is roughly where image generation was in 2021. Recognizably attempting the task, not yet reliable enough to trust. The question worth tracking isn't whether this particular product succeeds. It's whether parametric CAD generation converges through proprietary vertical tools like this one, or through open programmatic languages like OpenSCAD running against general-purpose models that anyone can swap. The commenter generating working models in OpenSCAD through Codex is doing the same thing Chiral is doing, but with an open interchange format and no vendor dependency. If the constraint solver is the language itself. If valid code equals valid geometry, then the CAD kernel becomes a commodity, and the intelligence layer becomes interchangeable. That's the architectural question hiding inside a product launch. Who owns the constraint graph? If the answer is an open language, every model improvement from every lab benefits every user. If the answer is a proprietary backend, you're renting your own designs. Let's talk about reading the most consequential code base ever written. I once spent 3 weeks debugging a data pipeline that kept silently corrupting records. Turned out we were treating a fixed width field as variable length, 3 billion characters, 4 possible values per position, and the schema was wrong. When I found the Genomics engineering guide at learngenomics.dev, my first thought was, oh, I've worked with this database before. I just didn't know it was alive. Here's what this guide does that most biology education doesn't. It meets engineers where they actually stand. DNA is a 3 billion character string over a 4-letter alphabet. Genes are functions. Proteins are the runtime output. The genome is the source code, and cells are the build system. The guide even uses a bakery analogy. 20,000 recipes, limited copies of each, but you can bake thousands of cakes from a single recipe depending on what the cell needs. It's object instantiation. It's a factory pattern. They don't call it that, but that's what it is. And this is where the first principles thing gets interesting. Strip away the biology jargon, and what you're left with is a constraint system that would be immediately recognizable to anyone who's built a compiler or a database engine. 2 complementary strands, base pair matching rules. A pairs with T, G pairs with C. It's essentially a checksumming mechanism that predates error-correcting codes by about 3 billion years. When cells divide, the helix unwinds, splits, and each strand templates a new copy. It's replication with built-in redundancy. We invented RAID. Biology invented it first and made it self-assemble. The guide is open. It's on GitHub. You can file issues. It's written by engineers for engineers, and it explicitly asks forgiveness from biologists. For the abstractions it draws. That's the right instinct, because the bottleneck in genomics right now isn't biology. It's computational. The sequencing machines generate terabytes. The analysis pipelines are where the actual science happens. And every engineer who can read a genome like they read a code base is one more person who can build tools that matter. The comedy here is that biology has been an engineering discipline this whole time. We just kept pretending it was too special for engineering metaphors. It's a code base. It has version control. That's what heredity is. It has bugs. That's what cancer is. And the documentation is finally getting written in a language the people who need to build the tools can actually read. 7 stories and we haven't had a proper cautionary tale yet. Pause. Let's fix that. 99%? That's the number that stopped me. A developer buys Castro, the podcast app, decides he's going to personally answer every single support email, and discovers that 99% of the time, no matter how carefully or kindly he explains why software costs money, the user's reply comes back angrier than their first message. Kindness as an accelerant for frustration, that's a result worth sitting with. The developer's name is Dabluck, and the experiment was simple. Use the product daily. Read every email. Respond thoughtfully. Hire a power user to help when volume got too high. The thesis was that human knowledgeable support would be an easy differentiator, that people would feel their subscription dollars were going somewhere real. 2 years later, he's writing a post-mortem on why it didn't work. The tax on field Chaco, what makes this piece worth reading. Pricing complaints are dead end because the developer has already thought about pricing more than any single email will. Bug reports are useful to receive, but miserable to answer honestly. We know about this, but can't fix it yet. We've never seen this before and probably won't prioritize it. It doesn't work is the whole email. Each category has the same structure. The honest response is the unsatisfying one, and a dishonest response would be worse. Run this forward. Imagine every small software company staffed a thoughtful human to answer every email with radical honesty. What you'd get is thousands of developers discovering the same thing. That support relationship is structurally asymmetric. The user wants resolution. The developer wants signal. Telemetry and crash logs already provide better signal than most emails. And resolution requires shipping code, not sending replies. Here's what's genuinely interesting, though. One of the commenters nails it. The vocal users aren't representative, and the real loyalty is built silently among people who never write in. The developer measured rapport by the tone of reply emails, but rapport doesn't live there. It lives in renewal rates and word of mouth from people who notice the app just quietly got better. The deeper lesson is architectural. When your users can only interact through a support inbox, you've built a bottleneck that frustrates both sides. The projects where support actually builds community are the ones where users can see the issue tracker, watch the fix get merged, even submit the patch themselves. That's not a utopian vision. That's how every healthy open source project already works. The inbox becomes a collaboration surface instead of a complaint box. What Dabluck discovered isn't that human support fails, it's that human support inside a closed feedback loop fails. The humans are fine. The loop needs opening. Completely different territory now. Story 8, pause. Let's talk about what it actually means to own the things you buy. A game dev with 20 years in the industry posted a comment that reframed this entire debate for me. Their suggestion: ban the word buy from digital storefronts. If you're selling a license, say you're selling a license. That's it. That's the intervention. Because the real question nobody in this discourse wants to sit with isn't whether discs matter. It's this: when did we agree that purchasing something doesn't mean owning it? PlayStation announced they're killing disc production starting January 2028. The article walking through why this matters is sharp. It traces the lineage back to Xbox One's catastrophic attempt to kill resale in 2013. Microsoft tried it too early and got laughed out of the room. Sony just waited longer. But here's where the engineering matters. Modern console discs are already barely physical media in any meaningful sense. They're license tokens that happen to be stamped on polycarbonate. The game installs from the disk, then phones home. The disk is a key, not a warehouse. And yet, that key could be handed to a friend, loaned to a neighbor, sold at a garage sale, the entire secondary market for games. The tradition of swapping cartridges and cases that built gaming culture for 40 years exists because a physical token is transferable by default. Digital licenses invert that default. Now, transferability is a feature someone has to build and permission. And nobody with a profit motive is going to build it. The commenters keep circling back to Steam, and they're right too. Valve doesn't enforce hard DRM. You can back up your game files. You can run them independently. It's not perfect ownership, but it's a closed system that chose to leave the window cracked open. The contrast with Sony's direction is architectural, not just philosophical. One platform trusts users enough to let bits exist outside the walled garden. The other is bricking the last exit. Meanwhile, the OmniDrive project, an open mod for optical drives that lets you rip Blu-rays including PlayStation games, dropped days before Sony's announcement. The timing is almost poetic. Every time a corporation seals a door, someone in a garage builds a window. That's not piracy. That's preservation. That's the ecosystem correcting for artificial scarcity. The question that should haunt every platform holder. If your business model can't survive your customers actually owning what they paid for, what exactly are you selling? And while we're on the subject of seeing what's really inside the box, let's literally look inside one. Let me work with what I have from the prompt context. The story is about Midjourney, the AI image company, building an ultrasound scanner device, with HN commenters raising Theranos comparisons and questioning whether the resolution is sufficient. Let me write the segment. Okay, let's be generous. Let's assume the best possible version of this story. An AI company with genuine expertise in image synthesis and visual processing decides to apply that knowledge to medical imaging. Ultrasound is notoriously noisy, resolution limited, operator dependent. If you could train a model on millions of ultrasound images to extract signal from noise, to reconstruct detail that raw transducers miss, that would be legitimately revolutionary. Cheaper diagnostics, portable imaging, healthcare access in places that will never see an MRI machine. The bull case writes itself. Now let's read the fine print. The archive paper, according to people who actually looked at it, shows resolution nowhere near what you'd need for clinical detection. The device apparently can't image airy organs like the lungs, which is a known limitation of ultrasound generally, but becomes a much bigger problem when your marketing implies you're reinventing medical imaging, and multiple people watching this video had the same three-word reaction. This seems fishy. Here's what's bemusing. Midjourney built its reputation generating images that don't exist. Beautiful, convincing, photorealistic images of things that were never real. And now they're asking us to trust them with images that need to be real, that need to correspond to actual tissue, actual pathology, actual human bodies, where a false positive ruins someone's year and a false negative ruins their life. The Theranos parallel isn't lazy cynicism. It's pattern recognition. A company outside the medical establishment. Charismatic presentation. A demo that looks better than the underlying science supports. The gap between the sizzle reel and the peer-reviewed resolution data. We've literally seen this exact sequence before. Through the bootstrapism lens, the question isn't whether AI-enhanced ultrasound is possible. It almost certainly is, and open research groups have been publishing in this space for years. The question is whether a closed proprietary company with zero medical track record is the entity you want between the algorithm and the diagnosis. If this technology matters, and it might, then open the model weights. Open the training data pipeline. Let 1,000 radiologists and engineers audit what you're claiming. If you won't do that, you're not revolutionizing healthcare. You're building a demo. The tools to improve medical imaging exist. The research is real, but trust in medicine isn't generated. It's earned. And right now, the resolution between Midjourney's claims and their published evidence has the same problem as their scanner. It's not sharp enough to make a diagnosis. So what happens when you take that open source ethos and apply it to physical manufacturing? Story 10. OpenPrinter. In 1984, IBM published the technical reference manual for the PC. Every circuit diagram, every BIOS listing, right there in a book anyone could buy. That decision, making the architecture legible, is why the PC won. Not because it was the best hardware, because anyone could build for it, repair it, extend it. The entire personal computer industry grew from that act of openness. 40 years later, your printer is a hostage negotiation. Epson, HP, Canon. They sell you hardware at a loss, then charge you $2,000 a liter for ink. They put DRM chips on cartridges. They push firmware updates that brick third-party refills. They designed a machine whose entire business model depends on you not being able to fix it or feed it freely. OpenPrinter is a direct challenge to that architecture. It's a compact inkjet with a refillable ink system designed for repair. With published hardware files, you can swap components. You can use whatever ink you want. You can fix it when it breaks. This is what a printer looks like when the business model is sell you a printer instead of sell you a subscription to your own hardware. Now the fine print matters. It ships under Creative Commons by NCSA, which means the non-commercial clause locks out the kind of ecosystem that made the IBM PC flourish. Several commenters flagged this, and they're right. Calling something open while restricting commercial use is a contradiction. True openness means letting someone build a business on your design. That's the test. The OpenPrinter team should drop the NC clause if they mean what their name says. It's also a crowdfunding campaign, not a shipping product. That deserves honest acknowledgement. But the design principles are sound, and the engineering approach, modular, repairable, refillable, is what every printer should have been for the last 20 years. The fact that it takes an independent project to build what incumbents refuse to tells you everything about where the incentives point. This has been your daily tech feed for Hacker News for July 6, 2026. This podcast is entirely AI-generated. Scripts by Claude Sonnet 4.7. Voiced by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that belongs to you. We'll see you back here tomorrow.